Hello everyone, welcome back to this series where we are working on some of these Project Euler problems using OpenAI Codex. This is Project Euler number 4, the largest palindrome product. So the problem is, a palindromic number reads the same both ways. The smallest 6-digit palindrome is made from the product of two 3-digit numbers, is 101101, which is 143 times 707. So 707 is a palindrome and this other number is a palindrome too. Find the largest palindrome made from a product of two 3-digit numbers which is less than n, okay, for some given n. So n will be between this number they already gave us, and I think that's 1,000,000, and t they'll give us up to 100 test cases. Okay, so it's relatively straightforward. Some constructive criticism I was given from a previous video is that what I was doing is I was copying and pasting this entire description into the OpenAI playground and then trying to get it to complete the sequence of words. And the problem is that there's quite a lot of already pre-made databases of solutions to these problems on the internet. So this is slightly different, but this is someone's Project Euler number 4, right? And they've actually put the description in. Now their description is slightly different. They had it with product of 2-digit numbers, so maybe this is a slightly older version. But it does actually have the description kind of as is, and then it contains some quite elegant solution which the person has created. And if you look at their database in general, they have a whole bunch of solutions to a whole bunch of problems. So I think what I'm going to try and do is be a bit more explicit with what I'm telling the Codex to do, and I'm not going to tell it please solve the whole problem from this description, because I think it's a bit too likely that it's just going to kind of Google one of these solutions and just plug it in directly. I'm going to try and aim a bit more low level and ask it to produce some specific functions, and hopefully that'll still be interesting. You know, it'll be a bit more testing of its capabilities than just trying to get it to solve the whole problem. Okay, so let's reset this input because I was trying it earlier. Let's take this setup. Okay, so this time what I'm going to do is I'm just going to put this in here and just ask it directly. So let's see what it does. Find the largest palindromic number, which again is quite a surprising thing to be able to tell it directly. So the fact that it knows the word palindromic may well mean that it's got this somewhere in its training set, but let's see what happens. Which is the product of two 3-digit numbers and is smaller than n. Let me just check I had that right. Yeah, which is less than n. Okay, and let's see what it does. Okay, so it's saying start with 0 and then take I in the range of all 3-digit numbers and j in the range of all 3-digit numbers and multiply them together, and if it's larger than the biggest palindrome you found, and I think this is testing whether you turn it into a string and then you turn it into a string and you reverse it, are those two the same thing? And then if so, make that your maximum palindrome and then just repeat this. So let's run it and see what happens. And I think from having done some of the other problems, it's relatively clear that this probably isn't going to do too well from a code speed perspective. Okay, so it's actually failed. And I guess here's the problem, right? It hasn't actually put in the condition that it should be smaller than n, right? Because it's saying go through all of these, and then if the product is greater than the maximum and it's a palindrome, keep it. So it's found these two enormously large numbers, and it's found the same thing for both ones, which must be the largest palindromes, which are the product of two 3-digit numbers. So it's not solved the problem there. Okay, so let's, maybe we should try with less than n. Let's see if that helps it to do something better. Yeah, there we go. So now it's got if the product is less than n, and if it's a palindrome, and if it's greater than the largest, so it's got these 3 nested if statements, then it's done it. Okay, so that's interesting. So it didn't like the word smaller, but it was okay with the word less, which is unexpected. Okay, so that's done those test cases. So this is what I was rather expecting, right? And the problem is that it's doing it in order n squared. So it's saying, go through and generate all of these things every single time you have a test case. So if I give you 100 test cases, for test case 1, generate this entire thing, and then find the largest one. And then for test case 2, generate this entire thing and find the largest one. So it's doing it over and over again. So I think we can probably make that rather better. So if I take all this out, okay, so maybe what I'll do is first, when the program first runs, let's say, make a sorted list of all the palindromic numbers which are the product of 2 3-digit numbers. Okay, so first we will generate an entire list of them. Okay, so it's defined this function, is it a palindrome? So it's said reverse that. And then it says start with a list which has 0 entries, go through for all 3-digit numbers, and then if it is a palindrome, append it, and then sort it. Okay, and then it's got some other code here, which I guess is just kind of junk. It's what do you want to do with this? It doesn't really know. So rather than making this main, let's just take the spaces out of that. So when this first runs, it's going to generate this list of palindromes. Okay, and then I'll say find the largest palindrome which is smaller than n. And okay, so now that we've generated the list of palindromes once, hopefully it will then, and this is quite a clever way of doing it, it will start at the end and work backwards, so it's going to iterate backwards through the list, and that's quite nice because I guess I would assume that the largest ones will be nearer the end, but it slightly depends what n is. If n is very small, then maybe that's slower, but let's see what that does. So this is a slight improvement, so it's still at order n squared, but it's only doing the n squared operation once, and then once we've done that, it's going to just search in that list to find the one that it wants. So let's see if that's fast enough. Okay, that is fast enough. So congratulations, that's finished. There was another solution that I saw to this actually. When I was rooting around earlier trying to find solutions, and that is that you can search backwards from the number n down to try and find the largest palindrome. So let's just try that. This may not work out, and I might abandon it because I don't want the video to get too long. But let's have a go. It's quite fun. All right, so what are the steps of this? So firstly, iterate backwards from n-1 to 0. Okay. Check if that number is a palindrome. So we find the largest palindrome, which is smaller than n. Check if that number is a product of 2 3-digit numbers. If so, print it and terminate. So what we're saying is start from n-1 and then go backwards, and as soon as you find a palindrome, check if it's a product of 2-digit numbers, and if so, print the number and terminate. Okay. So I think this is quite good, but I think this sys.exit is probably going to mess everything up because that's too big of a terminate statement, right? We still need to run this for the next test case T. So let's see what it makes of it. So I think maybe what's going to happen is it's just, so it's just doing one and then saying, okay, I don't want to do this anymore. So, and one of the things that's quite tricky is you can use a break statement here and you can say break, but the problem is, I say break here, then it's going to break out of this loop, but it's not going to break out of this loop and it's going to keep going. Like if I run that, because really what I want here is sort of double break. I want to break this for loop and I want to break the other one, so it's generating tons and tons of palindromic numbers. So I think I need to write something in like, and I don't know how I feel about helping the algorithm this much. I think I'm probably doing too much coding, but it's a bit difficult to know how to describe this in natural language. So done equals false, and then when you get to this point, we'll say done equals true, and if done, break. So that will give us this kind of double breaking behavior where it will break out of both for loops if it does it. And so I think this one might work. Yeah, so that's nice and fast. And this is probably a more elegant solution because it's not generating that giant list of 3-digit palindromic numbers. For example, if this said do this with 10-digit, the product of two 10-digit numbers, you wouldn't want to go through and generate the entire list first and then look for the largest one. You'd kind of want to do something like this where you start at some point and just examine a few candidates. Alright, well that's definitely enough for this video. I hope that's been interesting, and I'll see you in the next one.